In C programming language, there are different types of functions are available in the C compiler or in the C software. These type of inbuilt functions are known as library functions. These functions are categorized according to their activity or use of purpose, and as for this, they are stored in the different segment in the library, and these segments are known as the header files. Hello and welcome to Pathshala. I am Surajit Ghosh. In math.h is one of the header file of this library functions. Every header file have the extensions with .h. From math.h, there are different types of functions mathematical functions are available. Among them, the most functions which are basically used in the C programming language, in this video I am going to explain. So let's start with the first one. The first function is ABS function. This function is basically used to return the absolute value. It means if we input a negative value as an argument in this function, it always returns the positive value. In ABS function, we always use the whole number or integer type of value. So let's start. Before writing the program, we must to include the header file math.h. So I'm just going to write has include math.h, and then after I'm just assigning a value, suppose integer type int a equals to -7, and then after I'm destroying another variable to store the value, and then I am using the ABS function, and within this I am using the variable a. So you can see here the value of a is -7, and the ABS function is applied on the value of a, that is on the value of -7 in this portion, you can see. So the ABS function always return the positive value, but only for the integer or whole number system. Now the value of -7 becomes 7, and which is stored in the variable b, and now I'm just going to run it, and you can see the value it is here is 7. You can see this is the 7 is the value is obtained. Now if the value is float type, this time we are using the function fabs. For floating type, I'm declaring float c equals to suppose -13.5, and now I'm just using the variable c and storing d, and now I'm going to print the d with f. So in this portion you can see I'm stored the value c, float type value or fractional type value -13.5, and using the function fabs in this case, and with using this fabs function, it returns the absolute value, that means the positive value. So -13.5 becomes 13.5 after using this function. So I'm just going to run it, and you can see the value becomes 13.5, and the minus sign is just vanished. So these are the functions of ABS and fabs. ABS applied only for the integer type of number, and fabs function is used for the fractional type or float type value. Using the round function, we can round out a fractional value with the whole number nearest to it. And in this case, if the value of suppose in this case the value is suppose 13.5, so as the value of after the decimal places is 0.5, if the value of after the decimal place, if it is 0.5 or more than 5, then it is rounded to the bigger value, and if the value is after the decimal point is smaller than the 5, then it's rounded to the lower value. So in this case 13.5, so it is 5 or and for this reason it returns the value as 14. So I'm just going to run this program, and you can see there the output is come as 14. Suppose I'm just going to change the value, it is suppose 13.26. Now I'm going to run this program again, and you can see the value becomes only 13, not the 14, because the after the decimal place the value is 2.26. It is smaller than 5, and that's why it's rounded to the lower integer number, that is 13. And the next function is ceil and floor function. These both the functions are used to round out the values of a fractional number, and it is working the two ways. In case of ceil function, it returns the nearest integer value but greater than the value inputted by the user. And in case of the floor function, it returns the nearest integer number but never greater than the value inputted by the user. Otherwise it returns the lower integer value. So in this case the value is 13.5. so if I am just going to round out this function, the nearest integer value is 13 or either 14. In case of the ceil function, it never returns the smaller value than the value given. So if it returns 13, then the value is less than the value given by the user, so it returns the value of 14. So I'm just applied this ceil function on variable c, and after compile it, you can see it returns value 14. In case of the floor function, it also returns the nearest integer value, but the value which is returned is always be smaller than the value inputted by the user. So in this case 13.5, you can see this value is 13.5. The nearest integer value is either 13 or 14. But in case of the floor function, it never return the value which is return the value greater than the value given by the user. So nearest integer value is 13 or 14. So as the 13 is the smaller than the value given by the user, so it returns 13. So I'm just going to run this program, and you can see the value is obtained is 13. Now in this case, in case of minus 13.5, you can see the value of c becomes now minus 13.5. In this case, the nearest integer value is minus 13 or minus 14. But in case of the floor function, it always return the lower value than the value inputted by the user, and the lower value in case of minus is minus 14 for the floor function. Now I'm just run this program, and you can see the value is obtained is minus 14 here. Okay, but if I use the ceil function in case of if I use the ceil function instead of the floor function, then I'm just getting the higher value from the value inputted by the user, and minus 13 is the more higher value than the minus 13.5, so it returns minus 13. You can see the value obtained after the implied the function ceil is minus 13. Now I come to the next function, which is sqrt or square root. By using this function, we can find out the square root of any number. Maybe it is whole number or maybe it is fractional number. In this case, I'm write 9, and I'm going to find out the square root of 9, and which is going to store in b. So square root of 9 is 3. Now I'm just run this program, and you can see the value obtained after implementing this sqrt function on the value of a, that is 9, is 3. You can also implement this function in double or float type values. Now I come to the point of the pow function. In this case, pow function, we mention the first the number So number is a here in this case, and then mention the power value, so or exponent value. So it is stored in b, so 3 square, so a comma b. Now it is going to square the value of 3 and it becomes 9, which is stored in the variable suppose again b. And now I'm just going to run again this program, and you can see the value is 9. So by using this power function, you can make the power of any number. Suppose I'm just changing this value, suppose it is 3, and then I'm just run this program, so it becomes 27, as 3 cube is 27. So you can implement this power function on integer type value and in case of the float or double type values. Now the next function is CVRT or cube root. By using this function, we can find out the cube root of any number, maybe integer number or whole number. You can see in this case, I'm just going to find out the cube root of 27 and cube root of 25 for both type of integer type and float type value. And so cube root of 27 is it is 3, and cube root of 25, let's run, we can see what is the value is obtained. So value is 3 is obtained for the cube root operation done over the value of integer value of 27, and 2.924018 is obtained for doing the cube root operations on the value of 25 of float type. So you can by using this CVRT or cube root function, you can find out the cube root of any function with integer or float or double type data type. Now the next function is fmod function. By fmod function, we can find out the remainder after division, doing the division in between the two fractional numbers, maybe it is float type or double type. By fmod function, we only get the remainder portion. Suppose value of float x is 12.478, and suppose value of y is 3.12. so now I'm going to store it in the variable z. So I am using the fmod function, and in this case first we writing the divider and next I am writing the dividend, so x comma y, and now I'm going to print the value is z. So after division, the value of 12.478 by the value of 3.12, it retains the remainder portion. So I'm going to run this program, and you can see it returns 3.1180. Now I'm just changing this value 3.12 to 3.1, and now if I am just going to run this same program again, and you can find the value is 0.07800. So this is the remainder, and previous one also the remainder. So by using the fmod function, we can find out the remainder when actually two float or double type or fractional type value is going to divide. So by fmod function, we can find the remainder. Now the next function is exponent function. By using the exponent function, we can get the exponent value. Suppose e to the power x. Now in this function, we are going to mention the value x within the bracket of exp function. Suppose the value of x is suppose 5, which I store in the variable a. Now I'm just writing the variable a here, and then I'm going to run this program, and you can find the value is 148. So by using the exponent function, you can find the exponent value. But in case of exponent function, it is better to use the float or double type value, because exponent value may return the fractional value. But if you use the integer data type value to store it, it may transcript the fractional portion. So in exp function, you always trying to use the float or double data type value. So in this case, you can find the value is 148. So now I am going to change the value data type a and b by float, and now I am going to see what actually is going to change in this case. Now you can see the value is become 148.413162. So in when I just use the a and b variable as integer, so it return only 148 because the 0.413162 value is truncated in this case. So when we are just going to use the exp function, we must use the float or double data type values. Otherwise we lost or obtained the wrong result, and we lost the fractional part in this case. Now I come to the next function, LDExp. It returns the value after doing the 2 to the power exponent value, and then after multiplied by the a. So LDExp, I'm just writing here. So first value is double type value, always be, so a comma, then we are just mention the exponent value of 2, so it is suppose x. So now in this LDExp function, you can see the value of a, that is 0.30, is going to multiply the value of 2 to the power x. Now the value of 2 to the power x, that means 2 cube, that is 8, is going to multiply by 0.30. So the result obtained after doing this operation, that is 2.40, which is actually exactly correct. So by using this LDExp function, we get this result. Now I come to the next function, is log10. It helps to find out the logarithm value with respect to base 10. Suppose here the value is x equals to 3, and I am going to find out the value of 3 with respect to log base 10. So I'm just mentioning here x. So now after running this program, you can see the log 3 with respect to base 10 is 0.477121. If I am just going to change the value of x by 10, then it becomes log 10 with respect to base 10. It means the value must be 1. So I'm just going to run this program, and you can see the value obtained is here 1.00. So this is the use of the log10 function. Now we come to the next function, log function. This function basically used to find out the value of logarithm value with respect to base e. Suppose I am mentioning the same thing, only log function, then the value becomes, you can see, 2.30285. In this case, this value actually obtained on value 10 with respect to base e. That means log 10 with base e. Now the next function is sine function, cos function and tan function. By using all these functions, we can get the sine value or cos value or tan value with respect to the radian. So suppose if I am going to just find out the value, suppose sine for 45, okay, so I am just using the function sine, and in this sine function we always mention the angle or with respect to the radian value, not with the degree value. So the relation between the radian and the degree value is the value degree is multiplied by pi by 180, that is 3.14 by 180. So here it is, value is x, so x into 3.14 by 180 is the radian value for the respective 45 degree. And now if I just going to run this program, you can see it returns the value of sine 45. Now if I just change this value 45 with 90, then it returns the value is 1, and you know the value of sine 90 is 1. Now if I am just applied the same value with the cos functions, it return the value of cos radian. So you can see the value is returned is 0.00796. So this is the cos 90 value. And for the tan function, when you are just going to use the tan function, it returns the tan radian value. So tan 90, I'm just going to change it by 45, and I'm just going to run this program, and you can see the value of tan 45 is 0.99204. So by using this function sine, cos, tan, we can find out the radian value of an angle. So in this video I have explained the mostly used mathematical library functions. In the next video I am going to explain with a new topic. Till then, keep watching the rest of the other videos of this channel. Bye bye and have a good day.